Okay, my SS3 students are welcoming you once more to our online revision for your upcoming exam. Today I want to look at NECO 2007 Theory Part 1. And by now, we must be conversant with the nature of questions we are expected to answer. But theory has two parts, part 1 and part 2. Part 1 has 10 questions for you to answer 5. Each carries 3 marks. While part 2 has 5 questions for you to answer 3. Each carries 15 marks. So let's look at part 1. The question says, state 3 differences between mass and weight. 3 differences between mass and weight. And I told you, I have 2 ways to differentiate between 2 things. And I will advise you to use tabular form. Because some of you may say, mass is that, without using the word while, or whereas, or bit. It will score you 0. If the answer are correct. And the machine must be correct before you score you. So if you say mass is Newton, weight is kilogram, they are not compared. They must say why. So that's why I prefer using tabular form so that you won't have any problem. So I will say now, differences do with me. Mass, scalar, weight, vector. You see, I don't want to put grammar here again. Just put scalar quantity, vector quantity. But if you want to do it that way, I must say mass is a scalar quantity, while weight is a wasting time. Then you use tabular form. So I'll go again. Mass measure in kg. Spell out this. Kg means kilogram. Kilogram. So don't write kg. Weight measured in Newton. Don't say M. Thirdly, this is the first one, second one, third one. Mass measured, that is measured with, and that is a beam balance, chemical, or lever balance. Don't write the 3, you have to pick one. Weight measured with spring balance. Spring balance. Next one, mass, constant. Constant in all places. All places. Weight varies. Varies from place to place. Finally, mass, measure of quantity. Measure of quantity. Measure of quantity of matter in a body. Measure of quantity of matter in a body. Measure of quantity of matter in a body. Or quantity of matter a body contains. While weight, measure of of Earth's pull on a body. So how many of them? But the question says, give us how many? You have to give us 3. And I'm giving you many. So when you say, let me emphasize the last one. You see, it is easy for you to even blow to a marker on the table. And the marker will move. But you cannot blow your handset for you to move. So the handset contains more, more components. It's a matter has more components. So the amount of components in the matter is the mass. Then here, when you release a stone on the ground, the stone might come on the ground and make an impact. But when you release the cotton wool, there's no impact. So the force of gravity put it on the body, measure the weight of that body. The force of gravity is mg. So I won't go more about that. The second question says, a tennis ball is projected horizontally from a height of 30 meters above the ground with an initial speed of 20 meters per second. Calculate the horizontal distance traveled by the ball when it hits the ground. Take G. G means acceleration of the free fall due to gravity equals 10 meters per second squared. So what we are given here, we are given the height, we are given the speed, and G. We are given height to be 30 meters. Then V, initial speed, is 20 meters per second. And this G is 10 meters per second squared. Then find the formula that connects these three things and you solve your problem. So without wasting time, R squared is equal to U squared H all over G. Which means that R is equal to square root of U squared H over G. So that's the formula to solve the problem. You know it. It is in the projectile motion. So from here, what is U square root of, what is U? U is 20 times 20 times H 30 all over 10. You can't have the calculation. All over 10. So let us solve it and know the answer immediately. 20 times 20 times 30 equals 12,000 divided by 10. Here 1,200. 1,200. Square root of 1,200. Let us know what is the answer. $1,200. Two will be there, please. So 2 times 20 times 20 times H is 30 all over 10. So please, 2 will be there. 48.99 meters. 48.99 meters. So that's question number 2. Number 3 question says, define the velocity of a machine. Velocity ratio of a machine. Define the velocity ratio of a machine. That one is very simple. Velocity ratio of a machine is defined as the ratio of distance moved by the effort to distance moved by the load at the same time. Effort distance, the ratio of effort distance to the load distance at the same time. So that the same time must be there before you score. So, or in the same time interval. At the same time or the same time interval. So VR equals effort distance over load distance at the same time. So that is it. The second question says, calculate the velocity ratio of a plane inclined at an angle 60 degrees to the horizontal. Calculate the velocity ratio of a plane inclined at an angle of 60 degrees to the horizontal. That's the inclined plane, velocity ratio of an inclined plane. You know how to find it? VR of an inclined plane. You know what the inclined plane is? Just like this. So the angle here is 60. You have to find the VR. VR 1 over sine theta. 1 over sine 60. You get the answer. So what is sine 60? Sine 60 is sine 60 is 0.881 over 0.8660. Why I'm doing all these things? For you to follow. You should have known how to do these simple ones. So 1 divided by 0.8660. So to give you 1.15. 1.15. 1.155. Right. So that is number 3. Number 4 says, define the boiling point. Find the boiling point of the liquid. Boiling point of the liquid. Very, very interesting. The boiling point of the liquid is defined at the temperature, not point. Please, when you see something point, dew point, boiling point, melting point, they refer to temperature, not point. The boiling point of the liquid is defined at the temperature at which its saturated vapor pressure, commonly called as external atmospheric pressure of the liquid. And I say external atmospheric pressure, or I say normal atmospheric pressure of the liquid. The temperature at which its saturated vapor pressure is equal to the external or normal atmospheric pressure of the liquid. Then the next question says, state 2 factors which affect the boiling point of the liquid. You have 2 factors. I want to name the 2 factors. The factors are: number 1, nature of the liquid. Nature of the liquid. So, not the way kerosene boils, or not the temperature at which kerosene boils, the temperature at which water boils. The nature of the liquid. Number 2, presence of dissolved impurities or materials. Impurities. So impurities affect the boiling point. That's why when you want to cook stubborn food or stubborn meat, talk about the skin of she cow, the she cow, yeah, the skin is normal stubborn. Or I want to cook beans. I want to cook okra, breadfruit. Sometimes, not sometimes, in most cases you put impurities. Just like sometimes caustic potash, account. Or you can put even or thyme, all the rest. They are to raise the boiling point for you to cook it very fast. Another one is altitude. Altitude. That is the height of location above the earth surface. The height of location above the earth surface. So these are the three factors. The number 5 question says, list 2 types of wave apart from light wave that can be plane polarized. Plane polarized. The wave that can polarize plainly. Apart from light wave, you have water wave. Just let me give you this. Have rose beam. Here stand for this wave. There is a number. Rose beam. Yes. Now, no. So ripples, not really ripples. These 6 waves, they are known as electromagnetic wave, and all of them polarizes. Each one polarizes. So apart from the one, they say you shouldn't mention. They say you shouldn't mention this. This is visible light. Visible light, or just light. All these, each polarizes, plus water wave. So radio wave, invisible, radio wave, infrared. Radio wave, infrared, leave this one, ultraviolet, ultra, X-rays, gamma rays, and water wave, all polarizes. So have it there. The next question says, mention 2 applications of Polaroid. Question number 5b, 2 applications of Polaroid. Number 1, it is used in the production of 3-dimensional films. Application of Polaroid. 1, used in the production of 3-dimensional films. Number 2, used in sunglasses to reduce intensity of incident light. You see some ladies or gentlemen, sometimes they put they call it sunshade. They want the light, they don't want the sense of light to enter their eyes. They use it, but I warn you, if you have no eye problem, beware of putting on glasses. It may damage your eyes. So number 3, determination of concentration of sugar solution. Concentration of sugar solution. Number 4, studying areas of great stress in glass or celluloid. Studying areas of great stress in glass or celluloid. As is used to determine glare. So these are the uses of Polaroids. Number 6 says the distance between 2 successive crests of a wave is 0.664 meters. If the wave travels 43.2 meters in 1 second, calculate 1 speed, 2 frequency. So these are the wave. Simple question in wave. Wave question. It's always simple calculation. Have straight formula, which I know you are familiar with now. Then you have to calculate speed equal to distance over time. What is speed here? Speed here is 43.2. What is time there? 1.2. 1.2 is time there. 1.2. Therefore, speed should be what? Divide Going to arrive at 36.0 meter per second. The next one is frequency. V is equal to F lambda, where F is equal to V over lambda. What is V there? We have found V to 36. Then what is lambda? Is 0.664. If you work it out, you're going to get 54.22 Hz. Remember, for you to score the final answer, you must put the correct unit. You write 54. Let me warn you here. I don't want you to approximate. Well, I'm not asked to approximate. Please try to put the answer in decimal. So that is the answer to question number 6. Question number 7 says, copper of mass 0.33 grams is liberated by passing 1,000 coulombs of electric charge through a copper voltmeter. Calculate the mass of copper deposited when a current of 2 ampere is passed through the voltmeter for 5 minutes. This question will take us to electrolysis. Electrolysis here is electroplating. Electroplate deposited or the lot of electrolysis. So, and below it that M is equal to ZIT, where Z is electrochemical equivalent. So from here, and again, M again is equal to M over Q IT. So from here, you can now get out the mass deposited. This mass deposited. This mass is, you know that the Q then is equal to Q T. So from here, remember that you are not given Z. We can get Z from here. You can get Z from here. M over Q is Z. So we are told that M is, from the question, M is 0.33. 0.33. Current is 2. Time is 5. Have to convert to seconds, 60. All over, what is the Q? Q is 1,000. So from here, you calculate your answer to give you 0.20 grams. That's the question number 7. Question number 7. So what remains is question number 8, 9, and 10. It means that you have finished. This. So remind me, next time we meet, I will handle question number 8, 9, and 10. But before I round off, finally, let me show you. You can go and solve it. It's an assignment. It's an assignment. Go and do his assignment. Question number 8 says, look at the diagram, solve it. As somebody preparing for a serious exam, solve it. It's very simple. Not all that difficult for you to solve. So here is 24 volts. Here is 100 microfarad. Here is 40 microfarad. And here is 60 microfarad. So it says calculate the current in circuit above. That's all. Find the current. Find R. So you know what to do. Number 9 says state 3 peaceful applications of nuclear energy. State 3 peaceful applications of nuclear energy. Final number 10 says a nuclide A, Z, X emits in succession two alpha particles, three beta particles, and one neutron. Three beta particles and one neutron. To form a product Y. Represent the transformation by an equation. That's all. Represent transformation by an equation. So show equation to produce this and this to get your Y. So thanks. Let's continue. I'm still appealing to you to take this our teaching serious. Just like the same what you are seeing us, you are seeing our writing, you are hearing us. So there is nothing different, only that you're not here physically, but we are giving you everything. Pay attention to all subjects. There's no time for you to revise before you take. So some schools are not privileged as you are to have all these things going on in their school. Thank you.